Hey, everybody. So I have two things going on right now, just testing the waters. Welcome back to Ms.Davis Science Sessions, 30 minutes of science just for you. Shout outs to my assistant today. So we are doing a virtual spirit week at my school, and today is take a picture with your pet. I don't have that, or take a picture with a stuffed animal. So I figured, why not take a picture with an incredibly large bear, Barry Barrington, and it kind of helps that my school's mascot is the bear. So shout outs to everybody who's participating this week. If you don't know how our science session goes, and you guys, these are tickets from my Instagram science session with my students. They did a great job. So if you don't know how our science sessions go, if you participate in our science sessions, you earn tickets. Okay, right before we left, I changed the color of our tickets. I do a new color every quarter. So for those of you who have scholars, quarter 4 did begin yesterday, and we are officially starting quarter 4 academics on April 6th here in North Carolina. But if you're participating in my science sessions, you earn tickets. Yes, adults. You earn tickets too. If you're able to answer questions, you get your name in our beaker. And at the end of the week, I will draw a name. And let's just be real. We're social distancing. So I'm going to be real. I'm going to send you a Cash App, Venmo, PayPal, whatever works for you. But that is how you get your name in our beaker. You participate by answering questions. You participate by answering examples. And you let it all come back to you. All right, I am also streaming on YouTube. I'm trying that as well. I have a few students who, one, they're not following me on Facebook. Two, I want to be able to record these sessions for my babies who can't get on at particular times. So please bear with me today. Today talks about what my life is all about. Energy. All right, to get your first ticket into our beaker, who can define energy? How you do that? All you do is send it to me, type it in the comment box, and you can define energy. You want to define energy? Oh, God. I have another assistant, but my coworkers be tripping. Can't get good help these days, Barry. Right. Who can define energy? Type it in that comment box for me. It's okay. You can give me the very simple version of energy, or you can give me the very elaborate version, but I'm ready to get some tickets in our beaker. Define energy. Let's be honest. We use energy, but we don't really think about it that much. We uncommonly use our energy. So energy in my classroom, and when I'm talking to the social scientists, I always give energy like this. Yes. Okay. Yes, the exact definition. All right. Your name is now on a ticket. I'm going to give about 10 more seconds for your name to get on a ticket before I say the answer. Anybody else want to try to define energy? All right. We've got one person. There are so many different forms of energy. You are correct. And today we're going to talk about the main 5. All right. So energy is the ability to do work. And I tell my students that I always think of money when I think of work. So this is why our motion is work, energy. And in my classroom, we go up and down for energy because energy surges through us. The particles of energy are all around us in everything that we do. So energy is the ability to do work. And today we're going to do a little work. Look, I can't control the way I'm made. Today we're going to do a little work. You all know the formula for energy. And if you don't know the formula, you've seen the formula and you didn't put 2 and 2 together. I have an awesome shirt that one of my scholars gave me that I'll probably wear tomorrow that says, "You matter. Unless you multiply yourself by the speed of light squared, well then you energy." E equals MC squared. Yeah, that's that formula that you say and you just sound like you know what you're doing, but you do. It's the formula to find energy. The E actually stands for energy, okay? I mean, it's okay to be a teacher and be chiming in. Like, girl, get you a gift card, okay? E equals MC squared is literally the formula to find energy, okay? We don't go super in depth with it in 6th grade, but of course, the higher up you go in your science journey, the more you learn about it. You learn about energy being the speed of light squared multiplied by mass, okay? Mass times the speed of light squared gives us energy. M representing the mass, C, the speed of light squared gives us energy. But today, we're not focused on this. We're focused on the 5 main types of energy. There are 5 main types of energy, and I want this to be another ticket moment. So I'm going to give about 1 minute for you to chime in. What are the 5 main types of energy? They're not the only types of energy, but they're the main. So chime in. You've got 1 minute. It is currently 5:03. So at 5:04, tickets are closing. Go ahead and chime in to get your name in our beaker. What are one of our 5 main types of energy? I know. I hit the hints in plain sight. I'm okay with that. Okay. You're in the area. That's not the exact kind. It actually goes up under 1, but you will get a ticket because it does count. Anybody else want to chime on in? All right, you guys, the 5 main types of energy. I teach it in the form of melts. Okay, it literally spells out melts. You have mechanical, electrical, light, thermal, and sound. Melts. Mechanical, electrical, light, thermal, sound. Mechanical, electrical, light, thermal, sound. Now, in my room, I normally ask the question, what's the acronym that Ms. Davis gives for you to remember the 5 main types of energy? Melts, mechanical energy, electrical energy, light energy, thermal energy, and sound energy. Mechanical energy is special. Let's just be honest. A lot of us have been in the house lately, and I mean, we have been exhausting our mechanical energy. Mechanical energy is a mix between 2 types of energy. The energy that Barry Barrington is showing you, just lazy, and my energy. Barry Barrington is a representation of what we call potential energy. It is stored energy. It's energy that happens when an object has the potential to do other things. So if I stand here, which isn't easy, but if I decide to just stand here and do absolutely nothing, I'm storing energy. I now have the potential to jump, which I'm not going to do. I have the potential to, get low. I have the potential to slide, dance, move, do whatever you want it to do. A ball on the top of the hill has the potential to fall all the way down. Barry Barrington represents potential energy. Me, myself, I represent kinetic energy. Kinetic literally means to move. We talked about this last week when we talked about the kinetic theory of matter. And I'm ready for another ticket moment. So last week, I taught you the kinetic theory of matter. Who remembers what that theory said? You've got about 30 seconds to get your ticket in. Who remembers what the kinetic to move theory of matter says? I'm going to give you a moment because I want to make sure get these tickets in. I'm ready to fill it on up. The kinetic theory of matter. What does it say? And it's okay if you have to ask Google so you can get your ticket in. I mean, be great. Be great. Or join us for our science session so I can help you out a little bit. What does the kinetic theory of matter say? You've got about 10 more seconds. Okay. The kinetic theory of matter says that all atoms are in a constant state of motion, even solid atoms. My matter song, if you watch our science sessions from last week, we talked all about atoms, the periodic table, and the states of matter. In our matter song, it literally says solid molecules vibrate in their place. They have a volume and they have a shape. So we talk about how molecules stay in a consistent mode of movement. Energy, and Bill Nye, y'all know. You know how I feel about Bill. Bill Nye the Science Guy, a very old video of his, let us know that everything in this world is either matter or energy. So last week we talked about matter. This week it's all about energy. You're going to see me do this motion so much, it's going to be locked in your brains. And I'm okay with that. All right, so mechanical energy. There is a formula that helps me find mechanical energy. And I like this formula because it literally represents who we are. Mechanical energy is potential energy, or how I like to say it. Kinetic energy plus potential energy equals me, or mechanical energy. In my room, and I don't have another colorful marker here, KE, kinetic energy, plus PE, potential energy, equals me. Mechanical energy. Everything you do, you transfer mechanical energy to various types of energy. Energy can never be created. Energy can never be destroyed. Energy can only be transferred. In my room, we literally say energy can't be created. Energy can't be destroyed. Energy can only be transferred. That is the law of conservation of energy. The law. That means that so many scientists looked this up, worked it out, conducted experiments, redid experiments, went back, did it again, and understood that this law was law. Energy can't be created. Energy can't be destroyed. Energy can only be transferred. So that means when I move from potential energy to kinetic energy, I transferred the energy from one state to another. Let's do another example. We all have phones. Most of us have phones. And even though my phone is in a very tragic state right now, it still works. At night, or whenever you decide to close your eyes, you normally plug your phone up. I don't know about you, but I make sure I plug it up. I get a little upset when the energy from the electrical sockets doesn't transfer into my phone. And I wake up to that ding 5%. Energy transfers from the electrical sockets. It heats up or transfers to thermal energy to charge your phone. Electrical energy. We know about electrical energy. We've seen it. You've experienced it. Electrical energy can be found in a lot of things. Some of you did the potato experiment when you were a kid. You plugged up the nodes and you noticed that a potato produces enough energy to make a light bulb turn on. Light energy. Yes, I have my flashlight with me. Light energy. Now, there's something special about light. You can't talk about light without talking about waves. In Ms. Davis class, our favorite subject is waves. We know that a wave is a disturbance that transfers energy from one place to another. Again, a wave is a disturbance that transfers energy from one place to another. Oh, yes, the popcorn experiment, or even the solar oven experiment, one of my favorite ways to transfer energy. Light is a form of waves, not just any waves, electromagnetic waves. I've got to stop being like this. I'm sorry. Light is a form of electromagnetic waves. Electromagnetic waves are special waves because these are the waves that don't need a medium. I promise you, I could go on and on about a medium, but I don't want to jump ahead into another science session. So let's say light travels in waves. To be more specific, it travels in the electromagnetic waves. In my room, they love the EM spectrum because we always say there's something you should know. You gotta know the flow. And then you gotta say it goes radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, gamma rays. Those are the waves of the EM spectrum. You gotta know them. We love talking about light. Matter of fact, one of our favorite field trips this year, and when everything is over, I encourage you to go and check it out, was Laser Quest. It was the best representation of light. The first time we went into the dome, there was nothing to refract the light, so you had no idea where you were getting hit. I'll post some videos about that, but let me tell you, the way my knees was hurt and the way they came for me was out of hand. But the second time we went in, they added the fog, and that fog made it thick enough, or it was dense enough for us finally to see the light. So now I knew exactly where those lasers were coming from. So you have mechanical, electrical, light, and one of my favorites in my house, thermal. Let's be honest. Most of us have spent a lot of time either making foods that we said we were going to try, tearing some stuff up with some heat. But here in my house, I love candles. Shameless plug, this was one of my mini jobs, and now they have mini candles. They always had tea lights, but mini candles are cute too. Thermal energy. In my room, this represents thermal. Thermal energy is just another way of saying heat energy. Again, thermal energy is another way to say heat energy. We talk a lot about heat energy. You need it. Heat energy affects how you move. It affects the change from one phase to another. It affects so much. When you get sick, your body produces or speeds up the molecules so you know that you don't feel well. Heat energy is an indicator for us. So, thermal energy, and of course I'm not going to put my hand on this, and I would love, tomorrow we will do a lot of energy demonstrations, so definitely rock with us a little bit. I had a moment. We're going to come back to rocks later. Thermal energy is the important one because it affects how we move. Now for me, of course you can now see this smoke because that thermal energy is still slightly warming the air around us and it's making a whole nother ballgame. And the very last one, sound. You can hear me right now because a wave, a vibration that's coming from me going through the speaker or transferring through the speaker and vibrating your outer ear, going and amplifying in your middle ear, and then converting in your inner ear. Everything's science. I tell my students, I teach my students that you are a walking science experiment. Let's just be honest. How you move, how you live is science. So we've talked about energy today. Hopefully you're keeping your energy up with everything that's going on. I know right after this, I'm going to get some kinetic energy on and take a nice little walk. Energy is the ability to do work. And when work is done on an object, it either stores energy, my lazy coworker, or it excites that energy and it results in movement. Yes, you guys. I'm like this all the time. In front of the kids and away from them. I can't turn it off. So energy is the ability to do work. Tomorrow in our science session, we are going to do a bunch of energy demonstrations. So I hope you join us tomorrow as we do another science session. Again, from 5 to about 5:30. I say 6 to be safe. Hopefully you joined our Google Classroom. If not, I will definitely post that code on my page so you can join our Google Classroom and do some of these experiments at home. Do it with your students, do it by yourself, because tomorrow it's going to be a little messy, a little explosive. We're going to use a lot of energy. Thanks, you guys, for joining in. Thank you for chiming in, making sure that you get your name in the raffle. This raffle will happen on Friday, all right? On Friday, this raffle will happen at 5:30. And if you win, hopefully, you check your messenger so I can reach out to you and get your prize to you. Thanks, you guys. Join us tomorrow for another science session with me, and I'll see you soon.